So there are so many ways to have sequences. One common way of doing it is what's known as a geometric sequence. Geometric sequence means that to get each successive term, you have to multiply by some number. So in that first one, what we're doing each time is we have a ratio we're multiplying by. We're multiplying each term by 5. On the second one, we have a ratio where we multiply each term by 1/10, or 0.1. And on the last one, the ratio is -2/3. Every single time I look at a new term, I start with 1, I multiply by -2/3, I multiply that by -2/3, and so on, and so on, and so on. These are geometric sequences. Any sequence where each term, to get each successive term, you multiply by a number. What we want to talk about are the geometric series. A geometric series just means we're adding up a geometric sequence. The sequence being, hey, whatever the first term is, then multiply that by r, then multiply it by r again, and multiply by r again, and you keep doing that. So we're going to take a second and look at what a geometric series looks like and why it's so kind of easy to work with. So kind of a no-brainer here. The series is when you take the sequence and you just add them all up together. Now, the most convenient way is to start from term 0, believe it or not. I know that seems really weird. Just so you know, when we're adding something up with the summation, we can start with any number that we want. 0 is convenient because r to the 0 is just 1. That gives us our initial term. We can just say a is our starting term. You know, if we actually started with the first term, it's the same darn thing as up there, but I'd put r to the power of n minus 1. Gives you the same results. When you plug 1 in, r is still to the 0. You get your original term there. So that's what a series is, and it's really easy for geometric series to not only see whether they converge or diverge, but also to know what they converge to. Well, to see if it converges is easy. Is that ratio less than 1? If it's any number between 0 and 1, if we're talking the absolute value of it. Or in other words, if it's anywhere between -1 and 1, excluding 0. So when we look at these 3 examples, if you're multiplying by 5, do you think these numbers, when you add them up, are ever going to converge to something? Not a chance. They just keep getting bigger. Likewise, not likewise. In a different way of looking at it, if the ratio is smaller than 1, this series right here is actually going to converge. And so will this one. Okay, I know that's a negative number. It's not between 0 and 1, but the absolute value of that ratio, the absolute value of that is 2/3. So let's take a look at what happens when we actually add every number up. You ready to add up an infinite number of values? Since we know number 2 and number 3 converge, we can just sit there and say, boy, if we add all those up. Now, I know this says A, and it depends how this is written. If it's written this way, that way, the other way. A is your first term. A is your initial term. So you always take your initial term divided by 1 minus whatever that ratio is. So I've got 2 divided by 9/10. That looks nearly impossible to figure out. I don't think there's any chance we can ever do it. Except you can, dividing by fractions is the same as multiplying by, Strangely enough, folks, if you add all of these up and you continue on into eternity and longer and keep adding more and more terms, it will actually approach 29ths. Likewise, down here, pause, take a moment, see if you can figure this out. But when I figure it out, I'm looking at the first term divided by 1 minus my ratio. It is a -2/3 for my ratio. So please make sure you have that as a negative. That means I have 9 divided by 5/3, or 27/5. That's right. This is going to approach 5.4 when you add all of them up infinitely long. That's your first 2 examples and more. Here's 4 new examples. What's their ratios? If they converge, what's their sum?